This is going to be a lesson on how to use the quadratic formula to find the x-intercepts or x values for a quadratic. Just a reminder, if you have a parabola that crosses the x-axis twice, it will have two solutions. If it touches the x-axis in one spot, one position, it's going to be a perfect square. And if it doesn't cross the x-axis at all, it's going to have two non-real or complex solutions. So remember that your quadratics must be in standard form such that it is equal to 0. Identify the values for A, B, and C and plug them into the formula. One of the strategies you can do is to circle all of the values, coefficients, and the constants so that you're circling the operations so they become the signs of those coefficients. It keeps you from getting mixed up and missing out on transcribing those negative values correctly. One of the problems students have is putting in a b that might be negative. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Plugging those values in, I have to remember to square the b. This value will always be positive. This becomes a positive. And if I do the math, I get those values. Add up to 64 and the 504 underneath the radical sign, and I get 568. Now, this is more trial and error. If you have a very large number underneath the radical sign, you can always try a 4 if it's even to see if 4 will go into that number evenly. If it does, then you can factor out the square root of 4, which is 2. And in this case, 4 does go into 568 142 times. So I'm factoring out a 2 from 8, and I factor out a 2 from 18. And I factor out a 2, which is the same as square root of 4 from 568, and I get 142. Recall that these are two solutions, 4 plus radical 142 divided by 9, and 4 subtract radical 142 divided by 9. Problem number 4 is one of those problems where you are going to have to rewrite the standard form of the quadratic so that it equals 0. Notice that the b value doesn't exist. So we can add 1 to both sides, and when we put placeholders in for A, B, and C, we have A is 4, B is 0, and C is 1. Plugging those values, A equals 4, B equals 0, and C equals 1 into the quadratic formula gives me this setup. And if I simplify, I end up with the positive or negative of radical negative 16 divided by 8. Now recall that we can factor out the square root of negative 1, which is I, and we get radical 16. The square root of 16 is 4. So I times 4 divided by 8. 4 eighths is 1/2. So this is simply the positive or negative value of I divided by 2, or I times 1/2. Number 8 poses a similar problem in that it's not written in standard form equals 0. So subtracting 2 from both sides, you get 2r squared, subtract 3r, subtract 3 equals 0. Now we can identify our A, B, and C as a positive 2, a negative 3, and a negative 3. If you input A equals 2, B equals negative 3, and C equals negative 3 into the quadratic formula, you'll end up with 3 plus or minus the square root of radical, sorry, 3 plus or minus radical 33 divided by 4. I'm showing you the set notation here in that this solution is also acceptable if you want to separate out those two solutions.